Francel. I'm working under Dr. Nick Freeman for the project Scalable Methods for Encoding and Comparing Patterns in Commercial Sex Ads. So the background information is human trafficking is a pretty serious problem globally, and 27.6 million people are trafficked every year. And this is also a serious problem in the United States, and a lot of traffickers are using online escort websites to advertise and sell their victims. And so this is where the STAND initiative comes into play. This is an initiative at the Institute of Data Analytics, and it stands for Sex Trafficking Analytics for Network Detection and Disruption. And so what's happening is there's a high volume of online commercial sex ads, and it's difficult for law enforcement to go through all of this data on their own and find patterns in it to track down people. So it becomes really necessary to use large-scale automated analysis. And this is the main goal of the STAND initiative. It's to use data analysis techniques to find potential traffickers and trafficking organizations and report the findings to law enforcement. And so what STAND does is it scrapes advertisements on escort websites, finding key information like images, phone numbers, and unique keywords to link these posts together. And so you can look at these posts. They have images, phone numbers, and textual data. And what we do is we put them into a graph representation. So we link all the different data we have for a post together. And what we can then do is say, if two different posts have the same image or phone number, we can link those two posts together because that implies that it might be from the same person. And so what ends up happening is this works out well in some cases, and you do get really nice and distinct organizations, but in a lot of cases, we get this giant component with all these different posts that are probably erroneously linked together, showing up as this big, huge blob in the graph. And so why this happens is a lot of people are using stolen images or phone numbers, and there's also a lot of common memes or images used on these websites. And so this brings in my project objectives. And so to get rid of this giant component, we have to rely on textual data in the posts. And so what we do is we look at two posts that are connected in this giant component, and we compare post titles between those two posts to see if they're similar. And if not, we break the connection between them. But if they are, we can conclude that the two posts are from the same user and likely the same person and organization, and we keep that connection. And so currently what we use is TF-IDF to measure the similarity between these two post titles. So what TF-IDF is it's a method of measuring the importance of words in a document. And so you can think of this if a term appears more frequently in a document, but it's present in all documents, it has a low importance in the overall score. So things like the, a, or of aren't ranked highly. But otherwise, if a term appears in one document and doesn't appear in any other documents, it has a very high importance for the overall TF-IDF score. And so this ends up working surprisingly well for determining if two posts are from the same user by identifying these very unique words that have a high importance that individual users use. But it's not capable of fully capturing misspellings because, for example, if you change the E to 3, those are completely different words for TF-IDF. And then additionally, it doesn't really capture stylistic elements of the post or semantic elements of the post because it just doesn't understand that. So my research question is, can we do better than TF-IDF? Can we use language models to surpass TF-IDF's performance and better determine if two posts are from the same user based on the text? So what exactly are language models? Language models are machine learning models trained on textual data. And specifically, what we're looking at are masked language models. These are models that are trained on predicting missing words in a sentence. And you can see in the example, the movie is very blank. The next the model has learned throughout its training data that the most likely completion is boring. So the movie is very boring. And so what it's done is it's built up an internal representation of the sentence in order to figure out the missing word. And these models are able to, because of that, able to truly understand the sentence, pick up stylistic and semantic elements, and ignore misspellings. And so this leads into the current progress I've made. And so what I've worked on recently is constructing a new data set from posts scraped from a popular escort website. And this data set contains posts with user IDs. And so the user IDs give us a ground truth, because in a lot of data we look at, we don't always know if two posts are coming from even the same user, much less the same person. So having these user IDs available gives us the ground truth for determining if two posts are from the same person based on if they have the user ID. And so what I've done is I've constructed a new data set with pairs of posts, and then a label noting if they have the same user ID or differing user IDs. And then what I did is I fine-tuned a masked language model on my data set. And so this is the Distill-Roberta model. And the next thing I did is I wanted to get results. So I compared the performance of TF-IDF against my fine-tuned model. And I found the fine-tuned model to be better on all metrics on the test set. And so that's good. That's good performance. And so when we look at the actual results, the most important metric is recall, which is the proportion of positives detected out of all positives. And so we want to maximize this because we want to find the most positives so we're not missing valid data linkages at the expense. And we're not missing potential victims and potential traffickers. And we don't care as much about false positives because law enforcement is able to sift through and do investigations into that. So my next steps for this project are to compare TF-IDF and my new language model method to other methods. And so a couple other existing methods are BM25 and SPLADE. And these are basically algorithms that, similar to TF-IDF, ingest like a data set, and then you can see like how similar your input is to something else. And then additionally, what I need to do is cross-validation, and this is to get a good comparison between all these different methods I'm testing that is statistically usable. And so I'll be examining the performance of these new methods in production, and then I'll write up these findings into a scientific paper. And that is it. Thank you for listening.
So besides TF, IDF, and language models, are there other methods available for dealing with this problem?
Yeah, so a couple other methods are what I just mentioned is the BM25 and SPLADE. And then also another thing to consider is using a different language model base, because there's a lot of different language models out there. And we have to find a good trade-off between performance and performance on the test data set and like efficiency, because we're dealing with a high volume of data.
Yeah, could you expand on how exactly your model will help with the problem you talked about at the beginning with there being this giant cluster?
Yeah, so what we're doing with the model and what we're also doing with TF-IDF is we're using it to break connections in the graph. So based on if two post titles are very similar in this giant component, we can infer these two posts should probably be connected. But if two posts are very different, we can say these two posts should probably not be connected. And so once we've done that pass, we're able to more like, in large part, get rid of this giant component, which is good.
So I know text can contain a lot of other symbols. So how might a language model deal with, say, emojis or any other like emoticons of that sort of way? How does a language model really represent, like, how does it look at something that represents a similar emotion that humans may feel?
The language model I'm using has been trained on text data that includes a lot of emojis. And so over time in the training, it's learned that, one particular emoji for sadness and this other emoji for sadness are used in similar contexts. And it ends up, like whenever it encounters that, the model sees that as similar. And so that's how it ends up developing that representation of the emoji.